Probably not. Just leave it cracked so she can get in. Oh yeah, she's in here. She's in here. Let's see. All right. So let's hop back over here. Let me do this. Or actually, okay, guys. Let me turn it out just a little bit more. All right. So yeah, sorry, guys. All right. I'm just kind of letting students in. So I still got to work on my settings because it used to ping like whenever people would get into the waiting room. I gotta go and find that setting and turn it back on. Yeah, sorry we got started a little late. I just totally lost track of time. Let me see a few announcements. So yesterday, I don't know where everybody was, but I only had like one student show up. So we do meet 4 days out of the week: Monday, Tuesday, Thursday, Friday. Okay. I think Monday and Friday is like 5 to 5:50, and then Tuesday, Thursday is like 5:15 to 6:30. Ooh, I'm sorry. This car looks kind of weird. It's like backing up. It looks just really weird. It looked like they were about to get into an accident. But anyway, but yeah. So just be careful about that, guys. But yeah, we meet 4 days a week. I know, like on Blackboard, I don't have anything in the lab portion, but everything is in the our main page, right? Everything is there. Again, if you have questions, feel free to either type in the chat or unmute yourself. If you have questions, once you check, I just need you to check in. Remember, so we are doing the asynchronous setup this go around. So what that means is all I really need for you all to do is just check in each class. You don't have to stay, but just check in so that that way you have an opportunity to ask questions if you want to ask them. That's all. That's the main thing that I need. And then just be sure that you're completing your assignments on Blackboard, and then you should be fine. Now it sounds like it's behaving properly. So if there aren't any burning questions, we're just gonna take, so class lets out at 5:50 today. I don't really want to go past like about 5:40, maybe 5:45, and then we'll be getting out of here. And then hopefully you can enjoy your weekend, okay? So let's see, you can go like this. Let's hop back. Why are you jumping all over the place? There we go. Okay. And my pen. Oh no, my pen fell to the ground. Oh. These Apple pencils, they are expensive. They're like $100. So you try to take care of them. And okay, and I'm willing to do the following. So with this section, if we do finish early, then I'll let you out a little bit early. It just depends on how long it takes us to finish this. If whichever comes first, us finishing this assignment, or we hit about the 45-minute mark, whichever comes first. Let me see, is there anything in here? This is just like a introductory question. Type the number 1 in the box to answer. This is just an introduction, because you got to have a question from our book. Like if I'm pulling questions from another book. So that's what this was. I just want to get past this. Type the number shown in the pop-up. I don't want to see the answer. Click here to view the answer. 6. Done. I know I could skip it. I just was curious as to what it does. Okay. So hopefully everyone is doing well. I just want to go into the next question. Thanks. Okay. So let's take some time. Again, now we don't have to go through these questions in particular. I just kind of do this because generally students don't ask me questions direct. But this time in class is actually, it's like a study session. So like we can go over any kind of homework, any problem set. It don't have to be these questions in particular. But I also have noticed that students do kind of appreciate when you actually do take the time to go through the homework. Like they just resonate with it. So that way they always have it as a reference. So I was like, okay, that's something that I felt like we could do to be constructive with our time. And yeah, so that's why I'm doing it this way. Okay. So like I got some like gaming, like non-copyrighted music in my ear. So it kind of got me a little hype. And like I had the music playing. I was actually did my little 10-minute Easter egg while I was like doing a match right before class. So that music was going and I'm playing the match. I was like, oh, this feels good. Even though my team was garbage. Like they didn't know what they were doing. So I was just like, whatever. I'm just trying to have some fun. Okay, I'm trying to do what I have to do, but have fun while doing it as much as possible. That's how I get a lot of stuff done. but with the emphasis on doing what you got to do, but just try to have fun with it. Okay, we're asked to factor completely, and then remember that we can check by multiplying. So this is just more supplemental material. We finished out the homework for this week back on like Tuesday. Like it took us like 2 class periods to do it. So then for Thursday and Friday, I've been supplementing with like just practice on factoring. Because again, you are expected to already know factoring for this. But I know that a lot of times college algebra students haven't mastered or are comfortable with those concepts. So that's why we have this extra time to get practice on stuff like this. Remember that we can check by multiplying. Let's see. I'm gonna write this one down actually. I was kind of hoping I can do it without writing it down. Let me take some paper. This comes from section. So this is week 3. A general approach to factoring. A general approach to factoring. Okay. Let me see other announcements. So this is the end of week 3. You can anticipate exam 1 over basically the first 4 sections of the book. So sections 1.1, 1.2, 1.3, and 1.4. That exam should be available next Wednesday, and it'll be due next Sunday. Right. Keep in mind with all of our assignments, we get unlimited attempts, and you can actually submit assignments past the due date. But when you submit some assignments past the due date, there's a 10% late penalty. Okay, but that goes for any of our assignments on Blackboard. The main thing, I just need you to kind of get them in. And honestly, you can still get an A on assignments even if you submit it late. It's just that if it's late and you want an A, like an A minus, it has to be a perfect score. It'll be like a 90, right? So this is question number 2 from this assignment. This comes from an alternate book. Let's see. We're asked to factor. And then we have this 2n to the power of 6 minus 8n to the power of 5 minus 120n to the power of 4. Okay. Let's see. Oh, let's hop over to the tablet and let me see if this works this time. It seems usually it does that sound when it works. Okay. All right. So this comes from an alternate book, but we're asked to factor this, right? So whenever we're factoring, the first question we ask ourselves is there a greatest common factor? All right? Is there a greatest common factor? On our Blackboard page, I still have to update you all. I know I did it for my calculus group, but for you all, I still need to do the same thing. But once I get it fully updated, you'll see there's going to be a folder where I have like more practice on factoring, and it's like a summary of how to approach a factoring problem, right? I'll make this available. I'll make the official document available. I don't know if it'll help or not, but to summarize the summary, I know that's a little bit much. The first question we ask ourselves is there a greatest common factor, right? Is there a greatest common factor? So here, I'm just kind of writing this as notes. Let me see how to approach a factoring problem. Okay. So the first question we ask ourselves is there a greatest common factor? Is there a GCF, right? That's the first thing. Let's go style, like a little bit thick. Okay, let's copy. So then the next the next question we ask ourselves is how many terms are we factoring? How many terms do we have, right? And so it falls into like about 3 main categories, right? The first is like if we have 2 terms, and we actually did several of these 2 terms yesterday. So either we have 2 terms, right? Or we have 3 terms, or we have 4 or more terms. Okay, that looks like terms, so let's fix that a bit, right? And let's paste. Four more terms, right? So then Let me see, how am I gonna do this? Let's move this stuff down. Somebody is just like really loud outside. All right, okay. And let me do this, paste. And we're gonna put you here, all right? So then, and let me do kind of like this. Nope, undo. Okay. So this is essentially like the second step. We ask ourselves, how many terms do we have? Then once we identify the number of terms, it falls into one of three categories. Either we have 2 terms, 3 terms, or 4 more terms. The 2 terms that we try to factor, we actually did several of them yesterday. The first one that we kind of come across is like a difference of squares. Difference of squares. And that's where we're going to have something like a squared minus b squared equals a minus b times a plus b, right? That's the first, that's that one. Then we could have a difference of cubes. So difference of cubes, that's going to be something like a cubed minus b cubed equals a minus b, a squared plus ab plus b squared. So that's yesterday where we were doing the chair method in like yesterday's presentation. Third scenario here is going to be sum of cubes. Okay, so that's going to be like if we have a cubed plus b cubed, that's going to factor into a plus b times a squared minus ab plus b squared, right? So if we have 2 terms, it's usually one of these scenarios. I think I'm gonna shrink this down. Hopefully, you know, because this is really just supposed to be a synopsis and not like I wasn't really trying to go into this many details. So I'm gonna just kind of have it there like that. Okay. 3 terms, I've been pretty much using like if we have something like ax squared plus bx plus c, where we factor it into some form like this, where you have, you know, I call it the AC method of factoring. So you'll see me, I pretty much just use this one. Even if we have perfect square trinomials, I pretty much just use that one technique. Whenever I have a trinomial that can be factored, I kind of use the same technique and it works across the board. That way I can remember less and get more. We have several techniques there, but honestly, the AC method will get it going. And then if we have 4 or more terms, we'll use factor by grouping. Factor by grouping. Okay, so this is just like a summary of the summary. The summary that I want to share looks something like this, and this is the gist of it. There are some other details, but these are the main scenarios that we kind of come across, right? Actually, what I'm going to do, I'm going to move all this to one page. Okay, so, you know, I don't know if you can use that or not, but, and actually I'm going to move that to the top. Like right here. Okay, cool beans. Okay, so and I do intend to make these notes available. I did sit down for my other class. I just need to sit down for you all and make it available, so that'll be here soon. Okay, so now back to this one. So now if we're gonna try to factor this again, the first question we ask ourselves is there a greatest common factor? Do all the terms have something in common? They all have what? We can factor out a 2n to the power. They all have 4 n's. Right, so we can factor out a 2n to the 4. Okay, so from the first term, the 2 is gone. N to the 6 divided by n to the 4 is going to be n squared. The second one, that's going to be what? Negative 4n, and then minus 60, right? So, and again, we would check, if we were to multiply back, we should get the first line, right? Just to check, right? So to continue going forward, now we're looking for 2 numbers that multiply to give us negative 60 and add to give us negative 4. So what I'm going to do, I'm going to go through all the factors of negative 60. So if I go over here off to the side, I'm looking at negative 60. Negative 60 is what? 6 times 10. So 4, is that 4 times 15? Yeah, 4 times 15. So that's going to be negative 2 times 2 times 3 times 5, right? Let's see, 6 times 10, right? Okay. So now we're just going to go through all the factors, all the combinations that multiply to give us negative 60. And we're going to stop at the line that adds up to negative 4, right? So first we can do negative 1 is 60, but that adds up to 59. So those are not the two numbers we're looking for. We can do 2 and 30. That adds up to 28. So those are not the two numbers we're looking for. Can we do 3? Yeah, we got a 3 there. Now look at this. If we use this 3, we have 20 left over. 4 times 5 is 20, right? We have 20 left over. Those add up to 17. So we're going to keep going through the list. Next, we're going to look at 4. We got a 4 right here. If we use this 4, we have 15 left over. Okay. So if we do 4 and 15, those add up to 11. So those are not good. Let's keep going. Can we do 5? Yep. We got a 5 right here. So we can use that 5 and we have 12 left over. So if we use the 5, we have 12. These add up to what? 7? We're almost there. So these are not the two numbers. 5, can we do 6? Yeah, we can do 6. Notice on the left, I'm just going 1, 2, 3, 4, 5, 6, you know. So let's try 6. If we do 6, which are these two, we have 10 left over. Okay, I think this looks promising. All right, notice that these two numbers add up to 4. I think we want negative 4. So these were close. So then all we're going to do is reverse the signs. So we're going to say 6 and negative 10, and I think these are the two numbers that we're looking for, right? So what we're going to do, we're going to rewrite this negative 4n using those two numbers that we just found. Now here, so I'm going to introduce another technique that some of my students in the past would do at this stage, right? Normally, I've been using this technique called the AC method, where my A times my C in this case gives me negative 60. My A times my C, that's where this negative 60 came from. But what some students do at this stage, they do this technique called the box method, right? Box method looks something like this. Or some students use the X method. I don't know, the cross method. I don't know what that one is. It's the same idea though. So in the upper left-hand corner goes our leading term, which is the n squared. And the bottom right goes our constant, which is the negative 60. And then along the other diagonal, that negative 4, we use the two numbers that we just found. So we can say our 6n and our negative 10n, right? So then when we go to factor, if we look at the two on the top, what can we factor out of the two on the top? Oh, we can factor out n from both of those, right? So they both have n in common. What do the two on the bottom have in common? We can factor out what? Negative 10. Okay. So we can factor out negative 10 from the two on the bottom. What can we factor out of the two on the left? They both have n. They both have n. And what can we factor out of the two on the right? 6. It's like we can factor out a positive 6, right? So our claim is that, let's just copy, no, undo. Let's copy all of this. Copy, paste. So our claim is that this guy is going to be equal to 2n to the 4 times, now our claim is that it factors into the following. We get this n plus 6 and this n minus 10. And we could always check by foiling. If we foil, n times n is n squared. Outer is negative 10n plus 6n is negative 4n. You see it right there. And then last times last is negative 60, right? So then that's it. Now we know that we're in completely factored form because everything is either multiplied or divided. There's no like main addition, right? You got this thing times this thing times this thing. So everything is being multiplied or divided, right? So then we're gonna go with that as our final result. Okay. I don't know how obvious all this stuff is. It shouldn't, it usually is not. And again, like this is why we have the lab portion to try to address some of these things, because that's a lot of information to expect students to have mastered in preparation for this. Let's hop back over to Pearson. That looks good. And we're gonna try this one, right? Factor completely, simplify your answer. So we got 2n to the 4 times, we got this n plus 6 times n minus 10, okay? Boom, that looks good. Let me check the chat. The chat looks okay. Again, feel free if you have questions to either type in the chat or feel free to unmute yourself if I need to go back, you know. Also, we have tutors. You've already paid for tutors. Tutors are included in your tuition. So I know my presentation can be a little intense. It usually is. You know, it is what it is. But you definitely want, if you can't get it from me, you want to either get it from your classmate or a tutor or somebody. Like if you can't get it yourself either. You know, you have help. You just got to ask, right? You just got to ask. Factor the polynomial. Now this one, they already have the common binomial factor, right? So we have two terms separated by this plus. Both of these terms have something in common. They both have this y minus 3. So if we factor out that thing in the parentheses, namely the y minus 3, that leaves us with a plus z. There's nothing really to do there. All right, so we had the thing in the parentheses times a plus the thing in the parentheses times z. So we just factored out that thing in the parentheses and wrote what was left over. From a to z, y minus 3. Look at me over rhyming like a bee. I don't know. Factor. Okay, let's write this one down. Okay, let's write this one down. All right, so this is question number 4 from this assignment. This is taking way longer than I would have liked, but that's okay. That's what we're here for, right? To take our time. This comes from an alternate book. So I hope everyone is able to like stay warm. Yeah, I don't know how much, who's experiencing what, but last time I saw a map, it was like all of the country except for Georgia and Florida were like covered in ice. I was like, are you serious? And like today, I mean, it was like a really, really beautiful day today. I was like, I don't know what that means. It's kind of eerie. But I just hope that people are safe and, you know. I'm going to say a tangent now. This is kind of a tangent, but this is ideology. I heard something that was like, I think it was from the Daily Show, not from last night, but the night before last. But basically this woman, you know, wrote a book and like did research, and she realized that like basically like hatred and like what is it called? Can't even think, like not ego, but like being selfish and only being concerned for self, like racism and stuff like that. She was basically saying that like only person that, I mean, not only, but it hurts everyone, especially the ones that are exuding the hatred. She found that like if we all would work together, everybody would have more money. It's like she was like the oppressed, for them to come up, the oppressor has to come up as well. So for like the people that are oppressed, for them to make more money, the oppressor or the people in power, they have to make more money by default. So she was like, you know, when people exude hate and stuff like that, they're really just hurting themselves. But I saw that somewhere else. It was like, as long as we keep fighting, the only way we can like really free ourselves is if we all work together. Because again, everybody's gonna win when we do that. But it's just like, and I feel like that's the direction society is heading. I don't know how soon that's going to happen, but that's what I feel like everything is heading. But like, yeah, where we actually put our differences aside and work together towards a common goal for the betterment of every human being, every being. Like there's no reason for anybody to be without or have lack or whatever. Anyway, like I was saying, that was just a tangent. It was something I felt compelled, like I needed to say since I have an audience. I was like, well, you know, somebody can hopefully take that and help each other. So this is coming from an alternate book. What else do I write? Oh, we're asked the factor here. Let's see. And then we're given this 3r cubed, but it was really interesting to say the least. And let's hop back over to the tablet because, you know, I had to take my notes. And then we're going to go like this. Boop. And it looks good. Okay. Can I just do like, no, that's not working. Does that work? Almost. I can see what I need to see though. That's interesting. Anyway. Okay. So we're asked to factor this. Again, whenever we go to factor, we always ask ourselves, the first question we ask ourselves is there a greatest common factor? Do these terms have anything in common? All right. So it looks like we can at least again, I think last time we mentioned something about a divisibility test for 3. How do we know if a number is divisible by 3 or not? If the digits add up to a multiple of 3, then the number is divisible by 3. Let's look at this one. So we have 1 plus 9 is 10, plus 2 is 12. 12 is a multiple of 3, so that means this number is divisible by 3. So that means we can factor out 3 from both of these terms. And this is going to leave us with r cubed. Let me see, if there were 18, that's a 64, right? Okay. So then this is going to be one of the special factoring scenarios. This is where we have 2 terms. We want to factor 2 terms. This looks like a difference of cubes. Okay, so I think last time we factored difference of cubes. Let me see. I'm going to go like this. Oh, he's here. Okay, I was looking for him. I'm only missing. Today was much better. We're missing 2 students. Okay. Let me see. So I'm going to recap how we did difference of cubes last time, right? So first thing was like the biggie small. So we need a large set of blank parentheses. We need a small set of blank parentheses and a large set of blank parentheses. I usually do it in this fashion, kind of like this, right? So we have a small set of blank parentheses and a large set of blank parentheses. Okay. Then we list out, okay, what's being cubed? Well, in the first term, oh, and then we need to do the following. Right here, we need to include that 3. The 3 has to come down. Now, what's being cubed? We have r times r times r. And in the second term, what is that? 4. 4 times 4 times 4, right? Speaking of r times r times r, it's time for a bad joke, so brace yourself, okay? Get your responses to the bad joke ready. But you heard about that new pirate movie? It's rated R. Okay, I couldn't resist. Okay, it's really bad. I don't care. So let's see right here. So now, because the given sign was negative, let me see. Yeah. Because the given sign is negative, we have to ask ourselves: is this an example of the minus plus plus, or is this the plus sandwich? This is an example of the minus plus plus, right? So because the given sign was minus, our sign is also going to be minus. The second sign is always the opposite. The last sign is always plus, right? When we're doing sum or difference of cubes, you know, that's kind of the logistic there, right? So now, again, I use a chair method. Have these been rearranged? I use a chair method when I'm doing difference of cubes, right? So the first part of the chair is the back up here. So I'm going to put a 1. Right? And so that means the R and the 4 goes here. Next we have, I guess if you're facing the front, it's the left part of the chair. So then R times R is R squared. Next we have like the seat, the part that you sit on. That would be 3. So R times 4 is 4R. And last we have, I guess, the right side of the chair, or the other leg. That's our 4th part. 4 times 4 is 16. So then r cubed minus 64 factors into the orange, green, blue, and purple. Okay. Notice everything is being multiplied or divided, so this should be the fully factored form. Let me see if that's still in there. Paste. Nope, undo. Let's go like this. Let's go style. I like it like this. And let me go ahead and copy this. Okay. Okay, like this and like this. Okay, come on. Okay, that's fine. So let's try this. We're going to put this into Pearson. Let's hop back over to Pearson and let's see how do we do. Okay, let me see. Like no reaction. It is quiet. That's okay. 3 times r minus 4 times r squared. Nope, that's not squared. Squared plus 4r plus 16. Okay, let me see my time. We are like, this is like, my yammering keeps pulling for my time. I don't want to keep it for more than about 15 more minutes, right? So we're going to do whatever we can do in 15 minutes. It's only 10 questions. Let's see what we can do. Factor the polynomial. I think I need to write this one out too. Okay. So this is question number 5. It's actually the same header. So let me just get a copy of this, like from here to here. Copy. undo, and then paste. Okay, and this is what, number 5. Okay. Factor, okay. 8m cubed n to the 4 minus 40 m squared n cubed. Okay. Let's hop over here. Show it for the people at home. All right, so again, first question we ask ourselves is there a greatest common factor? Okay, what is that? For the constants, for the coefficients, we can factor out an 8. Both terms have an m, both terms have an n. The smallest exponent on m is 2, so that means both of them have at least 2 m's. The smallest exponent on n is 3, so they both have at least 3 n's. If we factor out 8m squared n cubed from the first term, that leaves us with, it looks like an m times n, m and n, okay? There's vomit on my sweater already, my spaghetti, right? So then if we factor out 8 from the second term, what is that, at 5? M squared n cubed, boom, just like that. I think that's it. Everything is multiplied or divided here. So we should be able to stop here. Let me just copy this, copy, come on. And let's paste. Copy that, okay. So let's go with this. Hop over to Pearson. Make sure that's showing. It is showing. So let's see. 8m, okay. 8m squared n cubed times mn minus 5. Looks good. Come check the chat. All right, let's go on to the next question. All right, yeah, this is an interesting one. These are fun. Like, you just gotta try to have fun. So, say you're working on your own and you're just like at a loss. That's what the question help is the main reason why I vouch for Pearson. It's very powerful. Most of the questions at least have a view and example, so they'll give you a similar that you can walk through. This one has ask my instructor, so like if the view and example doesn't make sense and amongst you and your peers you can't get it, that's when I would use the ask my instructor. I would recommend going to your peers first, like somebody that knows, because for some reason y'all are able to communicate a little bit better than I am with you all. Like the tutors and your classmates, they kind of say it where it sinks in. I still hadn't figured out how to make that connection, so I try, but I usually just kind of give all the details that I need, and a lot of times tutors are overwhelmed. Versus your peer might be like, don't even worry about that. When you see this, just do this, and they'll just do it just like that. And like I can't do it that way because I know there's a lot of other things that I need to say, and so I think they have it's a little bit different filtering system, but I recommend you want to get as many perspectives as possible. Let me do my header. So I usually get a copy of this guy. Let's copy, paste. This is question number 6. It's the same little deal. We got w to the 4 minus 81. Let's hop over to the tablet. Boom, just like that. Okay. W to the 4 minus 81. So it looks like we can do difference of squares. We got something squared minus something squared, right? So this is the same as w squared minus 9 squared, right? So now if we do difference of squares, that's going to be w squared minus 9 times w squared plus 9, right? We don't have, there's no way to factor sum of squares, right? We don't have a way to factor that, but we can do, not in the real numbering system, but we do have a difference of squares. So we do have a difference of squares, and we don't have a sum of squares, right? So difference of squares, that first binomial factors into w minus 3 times w plus 3, and then the w squared plus 9 persists. Okay, let's copy, let's paste, and boom. Okay, let's give it a go. We're gonna hop over, let me see, we wanna go here. Parentheses, w minus 3 parentheses w plus 3, parentheses w squared plus 9. Okay. Let me check the time. We got time for maybe one, maybe no more than 2 more questions. So we'll do 1, maybe 2, and then we'll call it a day. Let's give this one a go. So we made it about halfway. That's about right. Let me get a copy of this. Copy, paste. Okay. This is question number 7. Okay. We're asked to factor. We got this 36b squared minus 81c squared. Okay, those are perfect squares. Okay, do we have a greatest common factor? It looks like a 3, right? We can at least factor out 3. Let me see. That would be a 12, 6, 21, 2, 27. Let's not do the GCF just yet. Okay, let's hop over to the tablet. I was thinking. So first, let's just go ahead and do difference of squares. We got something squared minus something squared. So let's just go ahead and do that. I think we have we have a GCF, but I'm just going to do the difference of squares first. So what's being squared in the first one is going to be 6b minus 9c. Yep, I can see something there. Times 6c plus 9c. 6b times 9c, right? But notice all of these terms have what? 3 we can factor out. We can factor out a 3 from all the terms. So if we factor out 3 from the first 2, that's going to give us a 3. If we factor out 3 from the second 2, that also gives us another 3, right? The first binomial is going to leave us with 2b minus 3c, another 2b plus 3c. So it looks like the greatest common factor originally, we could have factored out a 9 from both of those terms. That's what I didn't really feel like getting down to the bottom of it, but that's okay. So then this leaves us with 9 times 2b minus 3c times 2b plus 3c, okay? Can I just paste? No, because I know I just used that. Let's copy. Now let's paste. Okay. And let's try this in Pearson. Okay. Let's see. So we have 9 parentheses 2b or not 3c. Then we got 2b plus 3c. Okay. Let me see my time. Okay. I know we have time for at least one more. Let's knock it out. So this is question number 8. Let me go ahead and write my 8. Okay, I'm going to copy my header. I see that. I'm going to check that. Let me finish this question and then I'll check the chat. I see the notification. Let's see, factor. So let me finish this question. We got this 12s squared plus 11st minus 15t squared. Okay, let's hop over to the tablet. Now, I'm not seeing a greatest common factor. I was about to do 3, but then that middle term doesn't have it. Okay, so what I'm going to do here, so normally it's 2 numbers. You might be tempted to say 2 numbers that multiply to give us, you might be tempted to say 15, and I would say, well, that's not correct, right? That's incorrect. It's not really 15, whatever 12 times 15 is, right? That's the AC method. 12 times 15. 150 plus 30, I think it's like 180. Is that right? I think that's right. Let me do this. Give me just a moment. 12 times 15, 180. Yeah, 180 is good. Okay. So we're actually looking for 2 numbers that I guess I'll do it over here. 2 numbers that multiply to give us a negative 180. And we're going to start with the line that adds up to 11, right? Now the 180, we got that from 12 times 15. So 12 was what, 4 times 3? So that's going to be 2 times 2 times 3, right? And then 15 was 3 times 5, right? So these are all the factors of 180. Let me see, 9 times 5 is 45 times 4. That sounds good, right? So now we're going to go through all the combinations that multiply to give us 180 and stop at the line that adds up to 11, right? So first we have -1 and 180, but that adds up to 179. So those are not the two, right? We can do 2. Look, if we use this 2, what's left over? 9 times, let's do 9 times 5 is 45, times 2 is 90. So I think those add up to 88. So these are not the two numbers. Can we do 3? Yeah, we can do 3. And this list actually, this list generally gets exhausted rather quickly, right? I know it looks daunting, but if you just do it, it usually comes down very quick. Now, if we use this 3 here, say we use one of these 3s, we have 4. 4 times 3 is what? 12. 12 times 5 is what? 60. So then 3 and 60, they add up to 57. So these are not the two. I think we can do 4, right? If we use this 4, 9 times 5 is 45. I think that adds up to 41, so these are not the two. Can we do 5? Yeah, we can do 5. Okay. 9 times 4 is 36. That adds up to 31, so these are not the two. We can do 6. Let me see. If we use this 6, 6 is gone. We have what? 6 times 5 is 30 left over. I think that adds up to 24. We're almost there, but these are not the two numbers. I'm going to kind of continue over to the right. We can't do 7. There's no 7 in our list. Can we do 8? There is no 8 in our list. We can do 9 though. 9, let's see. If we've used this 9, what's left over? 4 times 5 is 20. This adds up to 11. Oh, I think these are the two numbers that we're looking for. I told you we were close. I'm gonna just move it to the other side. I was preparing to go to kind of keep going. That's why I went over it like that. But -9 and 20, those are the two numbers that we're looking for. These are two numbers that multiply to give us a -180 and add to +11. Just for the sake of space, I'm gonna kind of move the second half of our list just over to the side. Okay, but those are the two numbers that we're looking for. So what we're gonna do, we're gonna rewrite this middle term using those two numbers that we just found. I'm gonna do the box method again. I'm just kind of fond of it. All right, and this will be it. Once we finish this is it. Now in the upper left hand corner is the leading term, so that's the 12s squared. The bottom right is the last term, which is the -15t squared. And then on the other diagonal, we use the two numbers that we found to rewrite the middle number. So we're going to say -9st, and we're going to say +20st, right? So now, if we look at the two numbers in top, what do they have in common? 3s. Looks like we can factor out a 3s from the two on top. I'm almost there. I'm aware of the time. If we look at the two on the bottom, we can factor out 5t. Let's factor out a +5t from the two on the bottom. The two on the left, what is it, 4? 4s. We can factor out a 4s from both of those terms. And the two on the right, -3t. All right, we can factor out a -3t from both of those. So then the claim is that, let's copy, paste. The claim is that this guy equals this, 4s minus 3t times, I'm coming, that's not a good, he's in my other class. Yes. I'm gonna let him in, tell him, hey, I don't have you on my roster. Okay. And then 3s plus 5t. Okay. Did we have a GCF originally? I don't think so, right? So this was, let me check this final result so I can let people out and we can answer questions. Let's copy. I would like to paste like that. Let me check this in Pearson, and let's wrap up. Okay, it was an adventure. 4s minus 3t, and then we got 3s plus 5t. Okay, so that's the box method for factoring trinomials. That's pretty much how, whenever I have a trinomial, if it is factorable, that technique that you just saw me do is how I do it. There are other techniques like perfect square trinomial, and if the leading coefficient is one, but the way you saw me just do it is pretty much if I have a trinomial and it can be factored, that's my go-to. It works like most of the time if it's factorable. Let's hop back over here. I'm just gonna do this paper, go like this. Just gonna kind of do this. Let me do this. Check it real quick. And I know we had something in the chat, so I'm gonna check the chat. Does this question need to be private, or can you ask it where it can be broadcast? If it needs to be private, I can like do a private session or whatever.
I mean, I don't think.
Okay, go ahead.
I just had a question about the course ID. I just had the ability to buy the registered book.
Yeah, book. Yeah. So the course, to access the course, is that loud? So it's no course ID. The way you access the course is through Blackboard. So you go to like our portal, you click on go to Blackboard, you click on our course, and I think it's like folder number 4. It says assignments. You want to open that up and you'll see the prompts. It'll say all assignments, and you click on that, and then
Blackboard with lab or the one without the lab? Because they have.
Yeah, I know we have 2. It's the one. There's only one. I have all of our stuff in one location. So if one doesn't work, then just try the other one.
And it'll be in content?
Yeah, as soon as you log in, it's going to be like the first thing that pops up. It's going to be folder number 4 that says assignments. It should go there like to that main page automatically.
Okay.
Yeah. At the bottom, it should say folder 4 assignments. You click on it. Then at the top, it's going to say all assignments. Once you click on all assignments, then it's going to like open up a pop-up and like take you over to Pearson, and that's where you put in your access code. So the course ID is basically, because you access it through Blackboard, that's how you find the course. And then the access code shows that you paid for the course.
Okay. Yeah. All right. I'll let you know how it goes.
Okay. Let me see. Are there any? Okay, I'm going to assume that there aren't any other questions. Feel free to either unmute yourself or type in the chat. Let me see. That should be showing. That looks good. Okay. If there aren't any other burning questions, guys, you've been awesome. Oh, yeah. I just let a student in. I just want you to know that you're not on my roster. I don't know if you're in my calculus course or not. If you're in my college algebra course, I think it was like an Edward something. I don't have you on my roster, so I don't know. I think I got an email, or my administrator contacted me earlier, and I said, hey, just let him in. So just follow up just to make sure, make sure that you're on the roster. If you're not, just follow up and just try to make sure to get added back. Okay. Okay. With that being said, all right, gentlemen, it was a pleasure. Just keep up the good work. Just main thing is check in. You don't have to stay, but just check in with each class and get your assignment submitted promptly. That's the main thing. Okay. All right, guys. On that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day.
Thank you.
Yep, my pleasure. Let's fix this up. That looks good. I'm not feeling it. I'm almost there. You can feel it. You just got to get some words in there. Anyway, all right, guys, we're gonna get out of here. I like this. Hang on. for that bass to drop. Gotta drop. Oh, here we go. Okay. See, now that experience to me, I see a skater, like a surfer, skater, just switching between those, or a biker, somebody doing like extreme stuff, like going on an off-road trail or something like that, or jet skiing, or doing some kind of stuff. That's what I do. Slow-mo, these fast-paced, slow-mo, pace kind of thing. Very good. All right, we out. That was fun. All right, we out of here.